Our next speaker and our last before our speaker panel is Jeff Vaughn for Security Innovation, who will be discussing the trade-off between hiring hackers and focusing on tooling. Jeff.
Hi. Wow, I can't see a thing. And I've been sitting in the dark all day. So this is hacker versus tool, use of which, when, where. So when to appropriately use a tool or a hacker. Push the button. Not pushing. There we go. Who am I? I'm Jeff. Hi, I'm a hacker. A security engineer. I do a lot of AppSec, pen testing, and advisory. So I put anything, I like hacking things, so put anything in front of me. That's what I like to do. And rarely I'm let out of my basement for speaking engagements, so I put on pants for you guys today. You're welcome. Bit of a quick disclaimer, I'm vendor and tool agnostic. I'll use whatever tool I can get my hands on that'll get the job done. And I do provide services in all areas of SDLC in terms of hacking services. So I'm a little biased on the debate on hacker versus tool. Before we get into the talk, we should really define what the qualities of a hacker, because obviously if you believe media definitions or what Hollywood would portray hackers, you know, there might be a different interpretation. So for me, at the purest sense, when I say I'm a hacker, really I think about developing creative solutions to complex problems. And I will research and deeply try to understand a problem. And I may leverage a tool in the pursuit of a solution. And then when we're thinking about a security tool or any tool, its main objective is to help solve a problem very quickly, automate some of the mundane behaviors or processes. A tool can be known for using signatures or behaviors and other analytics to inform its decision. And then it's really good for high volume testing, both large problems and large numbers of test cases. So for today, we're going to focus on hacker versus tool, sort of best practices or pro-cons in your SDLC. Now, you all may use a different version of this SDLC in some fashion or another, whether or not you're more agile or more traditional. For the sake of today's presentation, we'll go with this model. And there's subtle variances across the board. But we're going to look at each category and then try and determine when you would use a tool, when you would use a hacker, and what qualities and skills do they have to bring to the table in each instance. So at various points, you may want to engage a hacker or use a tool to help secure your product. And so hackers can be great for finding design flaws and knowing the whole picture of the problem or the project. And tools can be very thorough to prevent defined known issues. So if we're starting in the security requirements phase, and this is where you're trying to answer the question at an early stage, as early as possible, when you're developing a product of, how do I think of everything that could possibly go wrong with my application? That can be a long list of things sometimes. And depending on who you ask and which product the vendor is trying to sell you at the time, this is an area where if you invest quality dollars, you could save and prevent significant vulnerabilities early on, which could save you a lot of money. If you find a vulnerability in production, it could cost you 30 or 100 times, depending on who you're talking to, more to fix than if you fix it early on at the requirements phase. So bang for your buck, this is where the best place to spend your security dollars at first. Push, turn. The remote keeps dropping on me. Maybe the batteries are starting to die. So when we think of what is a hacker good at in the security requirements phase, they're probably going to find things the tools are miss. They're really good at finding edge cases, but I might not, or a developer or someone thinking like a hacker, might not necessarily be able to think of everything. So the types of tools you might look for is checklists or threat modeling, and most people cringe when I say that, and some sort of process in place to ensure that you're thinking of everything. So a tool is going to come up with a lot of the big issues, and then a hacker, or using a hacker mindset to creatively think about the problem, is going to allow you to come up with some of your edge cases. Up next is the design architecture phases. If I just go back one second. So if we were going to do for each one, who would be the one to use? In this case, it's kind of an even split. The tool is going to get most of your things, and the hacker is going to find the edge cases. So we'll try and do that for each one. In the design architecture, usually this involves some sort of use cases or user stories, data flow diagrams, server stack layouts, and this is traditionally something that there's not a lot of tools out there for. So as a advisor, hacker, engineer, this is my favorite area to perform or where to find vulnerabilities for me personally. What I love doing is sitting in a room, me and a couple developers who are designing a product, show me a flow diagram, and let me ask questions. And I'm going to ask questions until I find the perfect way to exploit your system. And this is a fun exercise for me. And hopefully that I can apply my hacker mindset to think about ways to perfectly exploit the system. The problem is this doesn't exactly scale well with large amounts of teams. And we just heard earlier about some of the teams are thousands of developers. Well, it's hard to have thousands of hackers to sit with teams to think about these problems. So if you could compartmentalize that into peer reviews, peer architecture reviews, maybe you could come up with a similar solution. So threat modeling is really one of the strategies in the design architecture phase. You could think about what are the threats posed on the system. There's the traditional way of threat modeling, which can be really process-driven and very tedious and time-consuming. Really, it's what assets do I want to protect, and what are the threats associated with my network, and how can I mitigate those risks? And there's not a lot of tools in this area that really help with the design architecture phase. So if you were looking for somewhere to plant your flag, maybe this is an area you could further develop. When we get into the development phase, there's actually a lot of stuff on the tool side that can help out developers. We're talking about in IDE plugins like Code Assistant development, where it tells you the secure way of doing a particular thing as you go to type it in. We talk about static analysis tools, and there's certainly a strong case for using them in many areas. With static analysis, you have only a limited class of vulnerabilities that you can detect, and you're going to get lots of false positives, and in some cases, thousands. But it is good coverage if you've got 1 million lines of code or large applications. And then how many of you have written or read secure coding guidelines? That's one strategy that companies try to implement, and whether that just becomes a document that gets sit on a shelf somewhere or not. But it can be a process that's put in place to help secure your development team. And then from a hacker perspective, I can try to train you to either think about security a little differently, or I can train you to think like me and think about how you would break and hack into a particular application. We can do manual code reviews as well, although that doesn't scale very well. And sometimes I'm able to find more complex vulnerabilities that a static analysis tool might not be able to find. You can also do peer code reviews to help mitigate that as well. So in this one, who would I give it to? I would probably say the tool for more comprehensive, and again, the hacker for those edge cases. So just a quick note on static analyzers, or static analysis. They're really good at finding very particular types of vulnerabilities. So think of source to sink issues, where the data comes in and where it's used, tracking where malicious input is executed. So things like cross-site scripting, SQL injection, and URL redirection. Static analysis is very good at finding that. It's good at finding secure misconfigurations. Every static analyzer I've used spews hundreds of insecure randomness errors at me all the time. It can find some session management issues and a ton of false positives. So if you've ever put your code through a static analyzer for the first time and you come back with hundreds or thousands of false positives, triaging that can be a big burden or additional work until you refine and polish that, and then you run the risk of missing a vulnerability. But they're not good at, so if you think of what they're good at finding, That's pretty good coverage, and the vendors are going to tell you about more things that it does. To what degree is debatable. But if you think about it, cross-site scripting, SQL injection, URL redirection, security misconfigurations, those are, and some session management things. Well, that's 5 of your OWASP top 10, so that's a pretty good start for early enough on in your development lifecycle. But it's not good at finding, and you need to be aware of this, it's not good at always finding authorization issues, a lot of authentication issues, abuse of business rules, and these are some of the more complicated vulnerabilities that an attacker will try to exploit. And in some cases, it's not always great at finding memory corruption or design flaws from the architecture phase. Then when we get into QA and testing, ideally we would have loved to have found all the vulnerabilities before this so that we can just check a box and send the product off into production. However, that's not always the case. If you find a vulnerability in QA, it could mean that fixing it might involve going back into the requirements phase or going back into the architecture development phase. And it could introduce delays. It could mean your product doesn't ship on time. And this is your first chance to do runtime analysis. And when you're doing runtime analysis, that's when you can find different classes of vulnerabilities as well. So for QA testing, I have a strong bias to hacker on this side. That's the main bread and butter of what I do. But a hacker can consider the whole picture of the application. However, we're often limited by best effort or time frame. I see a lot of apps where I'll do a 5 or 10-day assessment. Is that necessarily a fair time frame for me to get a full picture of the application and to perform an exhaustive test on a large-scale application? That can sometimes be a challenge. So often we're narrowed in scope as well. If combined with source code, I can get a better perspective into the application and then find more vulnerabilities and that you can hopefully fix. But then again, with large applications, it gets hard to cover the full, to guarantee full coverage, especially if we're looking for something like cross-site scripting or SQL injection. Testing every parameter manually is going to be a pain in the butt. So from the tool side, there's lots of tools in this area to aid a pen tester or a hacker. Fuzzing high volume of test cases, crawl large applications with good coverage. The modern scanners will do authenticated versus unauthenticated scanning, so then you're starting to find more of the classes of vulnerabilities. We can do better crash analysis and runtime debugging, but it still has, tools will still have trouble with business rules. So this one's an even split, depending on the size of your application. You probably need some combination of both. What's interesting is, when we get into production, the threat model changes and the hacker has infinitely more time and resources to potentially launch a vulnerability or an exploit against your system. So a hacker can now leverage social media, external resources, search engines to find and enumerate more potential vulnerabilities with your systems. We can leverage weak or vulnerable users. Now your users become targets of attack. And I may invest significant time or energy. So I might have only been able to put 2 weeks of effort in your QA testing before it launched. But now that it's in production, you have potentially exponentially more hackers going after your website. And you have potentially more, they could potentially invest a lot more time into exploiting your system. People devote months and years into iOS jailbreaks, or people I know will spend months trying to exploit web systems, like finding remote code vulnerabilities in Facebook. I'm sure you guys are aware of some of the incidents. So the tools on this side, now that it's in production, now you want to, yes, you want to prevent vulnerabilities, but you also want to detect them as well. So there's signature-based and heuristic intelligence, your intrusion detection scanners, your firewalls, all of your appliances that you can put into your network as well, abnormality detection and continuous runtime scanning. So in this case, it's a motivated attacker could have a strong advantage over you in this case. So you need a lot of tools and systems in place to protect you. So I'm actually done way early, which is a surprise to me. But I've got one more slide here. If I were to conclude on hacker versus tool, An informed hacker will know how to use each tool and when to rely on their hacker mindsets and instincts. So I will make use of tools at different areas, different phases of the software development lifecycle, and I will think about these creative problems to break into or find vulnerabilities within your system. And my advice to you is, a lot of you are developers, a lot of you are builders. If you can start thinking about how you might hack into your systems, maybe that'll enable you to make better tools and to try, at least, and play around and attack your application as a hacker might. It's important to note when you're thinking about tool versus hacker, it's important to learn the trade and not just the tool. The reason being, you don't want to become just a script kiddie who depends on tools all the time. Do make an effort to be tool agnostic so that you can learn a methodology for finding vulnerabilities. I don't just look at a system and guess at ways that it might be vulnerable. I take time to research it and take time to figure out how it works, to then figure out how I could misuse the application. Yeah, so I've got 4 minutes left to tell jokes and stories or anything, but thank you, everyone. You can follow me on Mr. Vaughn. Whoa.